Okay, before we get too much into the factor theorem, just another thought to have a look at. You've been solving quadratics by factorising and finding where the roots are. So if we take a look at this setup with a cubic, this will help you in some of your questions. If you notice, to find where the y-intercept would be, without expanding, you could just multiply those final terms. Whoops, and we'll know that it will go through at -2. So do bear that in mind, that's worth looking at. Now, on top of that, in mind, if we take a look at this function, we can see that the final term is -6. Using the idea we had here earlier, these final numbers must multiply to make this. So we need to consider what are all the possible factors of 6. So straight away, you can have a look. You've got +or-1, +or-2, +or-3, and +or-6. If I wanted to see whether that was a root or not, if I substitute that in, I should get 0. Okay, so let's test it out. So I'm going to get 1 cubed plus 4, 1 squared plus 1 minus 6. So 1 plus 4 plus 1 minus 6. So 4, 5, 6. So yes, indeed, I get 0. So 1 is a root. Now consider that then. If 1 is a root, so if 1 is a root, then that must mean the bracket that it came from originally would have been x minus 1, is a factor. So think about it like you've done in the past. You found these factors, and then that's helped you find the root. So now if we know the root, we can find the factors. It's the remainder theorem. We do realise that this system of dividing doesn't always work out. Now, when you get a question like this, notice you would first of all consider doing this. Now, that's fine, you will get there, but sometimes it takes a long time. An alternative idea is used similar to this. So if instead, rather than this one, I use the idea that if I substituted 1 in, let's see. So I get 2, 1 squared plus 2 times 1 minus 5. 2 plus 2 minus 5, so I get -1. So -1 is the remainder. Okay, so this is worth considering. It's a much quicker way in the types of questions you'll be asked in the exam.